so we're still going to be working with the quadratic formula. Like I said, we're kind of consistently going to see that theme coming up multiple times.
Stay with that here. DIY.
Okay, but here's the thing. The majority of the problems that we have been solving aren't even ones that necessarily force us to use the quadratic formula. I could solve this problem by factoring. Now, most of you probably don't want to pick factoring, especially when it's a trinomial where a does not equal 1. But there are other ways that we could solve it. Okay? There are, though, however, quadratics that we need the quadratic formula for. Okay? Solving by any other method would be much more complicated. Okay? And those are ones that are like this. So let's say 3x squared plus 7x minus 1.
Didn't we already do those?
You're going to see they're a little slightly different. They're going to start off exactly the same. There's going to be one slightly different piece. Okay, and just like we've been doing quadratic formulating. I don't know how to make that into a verb. Yes?
If it starts off the same way, how are we going to know the difference between?
You'll know. You'll see here in just a minute, okay? Okay, so step 1 says we need to be in the correct form. Is this in the correct form for the quadratic formula?
Yeah.
Yes. Okay, so then it says we need to find A, B, and C. So what does A equal?
3.
C. Yeah.
What does B equal?
7.
What does C equal?
1.
Negative 1. Okay, so then we're going to start plugging into the formula, just like we have been doing. Okay, so we'll say negative B, so negative 7, plus or minus 7 squared minus 4 times A, which is 3, times C, which is negative 1, all over 2 times 3. So far, we're exactly the same, right? What do we do next?
Put all of
The stuff underneath the square root, right? So we'll use our calculator to do all of the stuff underneath the square root.
My speech today,
I have a question. Is it still negative 7 or no? 61.
No.
I know.
Okay, are we getting 61?
Yeah.
Yeah.
Sure.
Mm-hmm.
Great. -7 plus.
I don't think it's a perfect square.
Right. Yep.
Why are you not putting the negative 7 squared if you're putting it down there?
So right here, this is the one that we take the opposite of it. This one stays the same. Now, Imelda, luckily, if we were to accidentally make this the incorrect sign, that squared takes care of it, and you'd still be fine either way. Okay, so 61 is not a perfect square. So when we take our calculator and we do the next step, which says to square root 61, we get out an irrational decimal.
Irrational.
It goes on for forever. It's an irrational number. So our choices are then to either A, try and write down an irrational decimal. How's that going to work out for us? Not too well, because we'd be writing for forever. B, we could look at the square root of 61 and make sure it's in simplest form. Okay, so how would we see if we simplify the square root of 61? What would we need to do?
Tree.
The tree thing? What does 61 split into?
30.5.
We don't want a decimal. I mean, we could do 2, but right, we don't want to split into decimals. Nothing, right? So we're done.
Bruh.
I mean, I'm fine with that.
Now, my students say exactly that. Well, Mrs. McKinney, that's awesome. If I'm done with that, then can I just leave my answer as that? Well,
Yes.
on that specific problem, yes. You can leave your answer as that. So if this was in Alex or on say testing, there'd be a button for you to put in the plus or minus. Or how many answers is this?
2.
2. So you might have to write in the -7 plus the square root of 61 over 6. And -7 minus the square root of 61 over 6. Okay, but we can't go any further with that, so we're there. We feel okay with that one? Okay. I just wrote it twice, once with the addition sign and once with the subtraction sign, because we don't always have that symbol to put in. The problem is that students then think that every problem that they do should end there. And that's not really the case. So let's say we have, how about,
I always want to
The wheelchair dog.
X squared plus 12x equals 40.
We just subtract the
You
40.
kid.
Right, so is this in the correct form to use the quadratic formula? No, so we already have to take care of something there. So what did we say we would do last week?
Subtract.
Subtract the 40, make this equal 0. What does A equal?
1.
What does B equal?
12.
What does C equal?
-40.
Okay, so what do we do next?
Plug it into the.
Start plugging it into the quadratic formula. Okay, now it might take you longer to decide what numbers to put where as you get more and more familiar with the quadratic formula. It should happen quicker and quicker. What do we do once we get it plugged into the quadratic formula?
Put in the calculator.
The stuff underneath the square root, right? Okay, so let's do underneath the square root. $304.
Sure.
Agreeing with the 304. Okay, so -12 plus or minus the square root of 304 all over 2. Right? We don't want to, we can take the calculator to square root 304, but we'll see that it's not a perfect square. Remember how on Friday I told you to always check and see if it's a perfect square first? You don't want to be prime factoring something that's a large number if it's a perfect square to start with. Okay, this is not, we don't want to write down a irrational decimal. We'd be writing for forever. So instead we need to start simplifying.
Can we divide it by 4?
Okay, so let's start simplifying. So 304. Okay, so if we pick 4 to start with, let's see.
76.
76.
4 goes into 2 and 2. 2 goes in here 38. 2 and 19. So let's see. 2 times 2 times 2 times 2 times 19. Do we have any pairs?
Yes. Two.
Yep. So we have a set of 2's and another set of 2's. So what does the square root of 304 simplify to? 4 square root 19. So now we have -12 plus or minus 4 4 square root 19 all over 2. This is still not done because we still need to reduce. The other rules that we know about math do not magically go away. Okay, so we know we would never leave a fraction of 12 over 2, and we would never leave a fraction of 4 over 2. Okay, so we need to look right here in these 3 places all at once. Inside numbers and outside numbers never get to meet. So we don't want to take that 19 with the other numbers because it's inside a square root. So we're just looking at the numbers outside of the square root, all 3 of them. And we are going to ask ourselves, can we think of a number that will go into 12, 4, and 2?
2.
And we can divide them all by 2.
Yes.
And so this becomes -6 plus or minus 2 square root 19. Because I'm taking -12 divided by 2, which is -6. 4 divided by 2, which is 2. And 2 divided by 2, which is 1. So you could have this all over 1. We just don't need to write it. Okay, we should then understand at this point that we cannot add these 2 things. Why can't I add these 2 things?
Because you can't add them. You don't want to.
The numbers don't.
How do we add with square roots? What has to be the case?
The same thing.
They have to have the same square root. This doesn't have a square root of 19, so it can't be added to something else with a square root of 19.
Oh,
Right? We said they have to have matching radicals. And I even specifically sort of put up an example like this and said we couldn't add them for this exact reason. Okay, so now not only do we need to be good enough at the quadratic formula, we need to be able to bring in our information with square roots and tie that into the quadratic formula as well.